In this question, we will focus on the need to find the mode of a group data. Before now, you already know how to find the mode. Mode is the observation with the highest frequency. But in this case, you have a group data. The biggest frequency here is 18. This is where you have the biggest frequency. And so what you have here is the modal class. This is a class that has the highest frequency, which is 10.8 to 11.2. So how do you find the mode of a group data? The mode of a group data, the mode is equals to the lower class boundary of that class plus the change between the frequency of the modal class and the previous class. I'm going to explain this later. So change in 1 plus the change in 2. Now change means difference in this case times the class width. It's possible you see this formula written in different form in different sources, but this is the most simplified formula. So let's talk about this formula first. So L, this L represents, L is the lower class boundary, the lower class boundary of the modal class In this case, we're talking about a modal class. The modal class here is that class that has the highest frequency. So the modal class is 10.8 to 11.2. Let's continue. Now the first change here is the difference between the frequency of the modal class, the frequency of the modal class and the preceding class. The preceding class, that means the class before. In this case, the frequency of the modal class is 18. The class before is 12. So the difference between 18 and 12. That's what the first change is. And then the second change is the difference between the frequency of the modal class and the succeeding class. We have the succeeding class. In this case, again, the frequency of the modal class is 18, and the next class, succeeding class means the next class. So the next class, the frequency is 14. L means the lower class boundary of the modal class. Change in 1, this is just like a change in 1, means that the frequency between the modal class and the class before, while change in 2 represent the frequency in the difference in frequency between the modal class and the frequency of the next class. And C here represents the class width. C represents the class width. C represents the class width. So let's get each of these values and then we can substitute in the formula. Starting with L. L represents the lower class boundary of the modal class. I hope that is taken now. So now let's get to the modal class. What is the modal class? The modal class is that class that has the highest frequency, and that is 10.8 to 11.2. 10.8 to 11.2 is the modal class. So let's jot this down. The modal class here is 10.8 to 11.2. We're interested in the lower class boundary of this class. So how do we get the lower class boundary? Let's consider the class before this modal class. What is that class before this modal class? That is, can you see that this is 10.3 to 10.7. That is the class before this modal class. The class before 10.3 to 10.7. So let me put this here. The class before is 10.3 to 10.7. What we want to do now is to get the lower class boundary. So to get the lower class boundary, find the difference between these. Let's adopt this diagonal principle. What is the difference between 10.8 and 10.7? We want to get the lower class boundary now. So the lower class boundary is what we want to get now. What is the difference between this? 10.8 minus 10.7, that's going to give us 0.1. So divide that difference by 2. Divide the difference by 2. You're going to get 0.05. Right? Good. So that means you're going to subtract 0.05 from the lower class boundary. This is the modal class. This is the modal class. You are subtracting 0.05 from the lower modal class. In this place, you have 10.8 minus 0.05. And so this gives you what? 10.75. So we are going to use 10.75 as the lower class boundary. We're using 10.75 as the lower class boundary. So we have our L. So we need to get the change in 1. We also need the change in 2. What is the change in 1? Remember I told you change in 1 is the difference between the frequency of the modal class and the preceding class. So 18 minus 12. 18 minus 12. 18 minus 12, and this is going to give us 6. So now the next change in 2 would be the difference between the frequency of the modal class and the succeeding class. That means the next class. So 18 minus 14. 18 minus 14. So 18 minus 14, and that is 4. And so finally the class width. How do you get the class width? You find the difference. Just find the difference. To get the class width, find the difference between these two. The difference between these two, 10.8 minus 10.3. Or you just pick anyone, 9.8 minus 9.3. To get a class width, subtract the difference between the lower class interval minus the lower class interval of the class before. Any one of them. Or you just go this way, 12.8 minus 12.3. You're going to get the class interval here. So I want to go with 10.3 minus 10.8 minus 10.3. So my class width, 10.8 minus 10.3, and that is 0.05. So now we have all our values. We have the value of L, which is 10.75. The change in 1 is 6. The change in 2 is 4. and the change of the class width is 0.05. So let's substitute in the formula. The mode is equals to the lower class boundary plus the change in 1 divided by change in 1 plus the change in 2 times the class width. So 10.75 plus change in 1 and 6 over 6 plus 4 times 0.05. So what is this gonna give us? 10.75 plus 6 over 6 plus 4, that's okay, let's just get it straight. 6 plus 4, that's 10. 6 divided by 10, that's 0.6 times 0.05. Let's confirm that. Is that 0.05 or 0.5? Okay, this should be 0.5. This is 0.5. 10.8 minus 10.3. 10.8 minus 10.3 is 0.5. Please correct that. 10.8 minus 10.3 is 0.5. So this is 0.5. I have 0.5 here. 0.5. So let me also correct this here. 0.5. So 10.75 plus 0.6 times 0.5 will give us about 0.3. And finally, the mode is equals to 11.05. The mode is 11.05. Thank you for watching and staying tuned. Please leave your comments in the comment section. Let me know if you understand this or you have other formulas used to find the mode of a group data. Okay, I'm going to see you in the next problem. Bye-bye.